technicality of 3D printing. So we're going to love to hear some feedback on if this content is valuable to you. If you want to see more content like this, we have plenty to show. So the agenda we're going to be going through today, we're going to start with a little bit on Fisher Unitech and myself. We're going to dive deeper into what is lean, what is lean manufacturing, what does that actually mean. We're going to go into some very specific terms and tools of lean, one being DMAIC, which I'll elaborate on later, 5S, one that a lot of you may already be familiar with, COPQ, a value stream mapping process, and then a little bit of question and answer at the end. So let's begin. A little bit about Fisher Unitech. We're one of the largest value-added resellers in America, in the United States. We have an award-winning team, both on the software side as well as the hardware side. We support over 15,000 customers in the U.S. between our different product lines and vendors. As I said already, on the software side, we have SolidWorks and SolidWorks Elite members. We're a Diamond partner with Stratasys, and we're also a Diamond partner with Desktop Metal, who also coincidentally has a base here in Massachusetts. And in terms of the reliability and our experience with technology, we have over 2,200 printers installed and supported across our territories. Between organic growth, mergers and acquisitions, we work with these things quite a bit, and that's why we have such a dedicated team to all this, because that's a lot of bandwidth to take care of. So we need this type of experience to be able to support you professionally and in the speed that is required. We go everywhere from the tip of Maine all the way up to about St. Louis and the Chicago area, so about 2 different time zones there. And again, it's an expert technical team. We have over 500 certifications, both on the hardware and software side, and over 50 experts that are specialized in this type of service, both application engineering perhaps, service, and then technical support. A little bit about me. As I said, I'm Boston-based in the lead of New England. I'm a 3D application engineer, meaning that my primary job function is working with prospective customers and customers like yourself to better understand what this technology can do, and not only what the technology can do, but how it directly affects your bottom line and how to integrate this technology into current and future process. I'm also a certified project manager, and I'm also a certified Lean Six Sigma Green Belt, which basically means I am an optimization and efficiency professional, and my educational background is in analytics. As we move forward, I'll dive deeper into what exactly that means. A little bit about partners. So we like to think of 3D printing or additive manufacturing, whichever you want to call it, into 3 distinct categories. So there's the start area of it, so getting the model going. So designing it in SolidWorks, maybe taking a scan. 2 of our partners on that end are SolidWorks again, as well as Artec 3D scanning. Then the next phase is the actual printing process. So our main product line and our oldest vendor and value partner is Stratasys, who invented fused deposition modeling as well as polyjet technology. We also have Desktop Metal, who invented bound metal deposition. So basically you're going from the Stratasys thermoplastics and photopolymers down to actual stainless steel with Desktop Metal, as well as some future metal that'll be coming out. And then one of our newest vendors is Now Dimension. So they 3D print multi-layered PCB circuit boards. And finally, and this is a historically underutilized aspect of 3D printing, the post-processing. And our vendor there is aptly named Post-Process, who has created and invented and is now supplying in our territories automated support removal as well as surface smoothing technologies. So that's a little bit about me, Fisher Unitech, and all of our partners. Now, I want to be very clear. This presentation is meant for managers, not analysts. What that basically means is, once again, we're going to be going over management tools, optimization, and tips and tricks on how to just better manage a team or better manage a fleet of machines. If we want to go deeper into the actual math and analytics and statistics behind Six Sigma, maybe we'll do another webinar at some point. But right now, we're just talking about management. So one of the biggest aspects of management, as a lot of you most likely know, is constraints. A really good matrix to have in mind when talking about constraints of any project is budget, time, and scope. And you always want to be somewhere in the middle. So if there's going to be more time involved, it might affect cost and scope, respectively. And one aspect of 3D printing that can help alleviate this and not strain your team out or increase bandwidth too much is the ability to actually control and choose specifically what level of quality and time you want certain parts printed for different reasons. One great thing to bring up is different resolutions. So FDM, we could go all the way down to 5/1000ths of a layer thickness, very fine, very accurate. And then you go all the way up to 13th thou, which means that you have thicker layers, which means you're depositing that material faster and your print can come out faster, although you're sacrificing a little bit on the resolution side. So you could control up to that point. PolyJet is even more detailed, down to 14 microns, which is way more than 5/1000 of an inch, and also orientation. So the lower or flatter you lay down your parts, the faster that will print, even if it's the same geometry. And here's a little close-up of what we mean by these different layer heights and thicknesses. As you can see, as you go higher up in the Z dimension or higher up on the height of that part, if you're laying down thicker layers, you'll be able to achieve the height of that part faster, and you can dramatically reduce the time it takes to print that out. So what is lean? Lean, at the end of the day, is a mindset that permeates all of an organization, but it almost always has to start with management. And the philosophy, or the guiding philosophy behind lean, is you always have to keep in mind the voice of the customer. That's the value that they decide, not necessarily you or your team. And some of the cornerstone talking points about lean and some of the goals of lean is increasing efficiency. One aspect of increasing efficiency comes in the form of DMAIC. It's a Lean Six Sigma method, so it stands for define, measure, analyze, improve, and control. We'll be diving into that a little bit deeper soon. Next thing we want to talk about is reducing waste. Now, this comes in the form of cost of poor quality, which, as you see by this iceberg analogy, there's a lot of cost of poor quality that you might see immediately. So unused office supplies, inventory, processing work, equipment failure. But there's a lot, if not the majority, under the surface. Things that you might be analyzing or even aware of that has cost you more time, more delays, and ultimately more cost. And the ultimate cost of poor quality is lost business, which none of us want. And the third tier is reducing delays, as I already previously hinted upon, which really comes in the form of getting a more streamlined process. That's where we're going to be talking about value stream mapping. And the thought behind this is most, if not all, delays can really be attributed to a very poor, muddled, confusing, or not very well thought out process. So first we're going to dive into DMAIC. So again, it is an acronym. On the define side, we're talking about defining the actual problem that your department, team, customers maybe, your sales team is facing, and then write it down. So you have a specific goal that you want to reach, which is alleviating this problem, refining this problem, or at least minimizing the damage that this problem is giving you and your team. Next, you want to talk about measurements. Measurements mean metrics to define what's currently going on in your process, what the current problems are and why, and the numbers associated, and what you want that goal to be in terms of numbers. If you are only making $500,000 off a product line, maybe you want to make $1 million. So then we have to figure out how to get from 500,000 to 1 million. The next step is analyze. So again, taking that data and using it to better understand what we're dealing with. So why is that number so low, or why is this cost number so high? Improvement. So again, using the analysis that we did based off the metrics that we recorded to not only approve and initiate change we want to make, but also just to get the justification, which is apparently what approve means. You can't necessarily go pitch an idea to your boss without really defining as clearly as possible how this affects the financial structure or the financial health of the company or department. So having analytics and numbers to clearly justify where there's a big area of cost or a lack of revenue is going to go a very long way in being able to promote your own ideas and promote your own products as well as projects. And then finally, control. So establishing a certain system of checks and balances to constantly be able to see where your process is at, if it's performing to the level of standards that you want it to have, and what it looks like compared to what the process used to be. And this all boils down to reliability and repeatability. And we're going to talk about that more and how it directly correlates to the hardware of 3D printing. But in terms of reporting, we're going to talk about our software very briefly. So CAD Print. CAD Print is kind of the all-encompassing server for most soon-to-be all Stratasys hardware. And this is browser-based, or you can see all this just from Google Chrome or Mozilla Firefox, whatever you're using. And we want to talk about some of the different screens you have available to you when utilizing your printer fleet. So the first thing we want to talk about is the tab is just reports right there next to schedule, which we'll talk about schedule a bit later. And this tab right here is talking about how many printers you're talking about. You could select one specific printer, a couple in one specific office you might have somewhere in the country or in the world, or your entire fleet in this stance right here. And then the timeline you want to look at, so the last 30 days, the last year, the last 5 years, whatever it might be. And this tab right here is talking about material usage. So how much material we're using across the fleet or for that one machine, broken down into cubic inches. And you can see both here on the histogram graph, as well as the material names and just the bare bones numbers down here. The next tab within the reporting function is printer utilization, meaning how much time you're actually using this machine throughout the day. If you're using 20 out of 24 hours, that's going to give you one number. If you're using 1 out of 24 hours, it's going to give you another number. So you have that in the form of a chart, as well as some more specific details down here, as I already mentioned. And usage in a percentage, printing time, and then not printing time. So that's really important. So obviously, if you're buying a machine and you haven't used it at all for a week, a month, 6 months, that's really going to affect the ROI you can make on the machine. So you're going to have the ability to see that number directly and see how far away you are from actually achieving ROI because you're not using the technology in an optimized or efficient manner. And then last but not least is printer history. Now this is a great area of the reporting function in GrabCAD. It has built-in accountability, so you're able to see specifically who is sending jobs to what machines, the name of the jobs, which we'll talk about the importance of that a little bit later, when it was started, when it was completed, how long it took to print, the status right now, was it canceled, was it aborted, is it successful, did it finish, what happened there, what materials we were using, and then even better, if you do have an analyst on the team or an engineer that likes numbers, you could actually export and save all this data into a CSV to get some more number crunching down in a Excel spreadsheet. Now, the material usage, the printer utilization, the printer series we talked about, that is the first aspect of DMA. So define, measure, and analyze. You're defining what materials and machines you're using. You're measuring the consumption, the time, the printer utilization, and you have the metrics to back it up to analyze that further. But where do we improve and where do we control? There's a couple different areas where we can achieve this. So first is errors in your CAD models. This is also built into GrabCAD Print. So if you have a model that comes in and you have a red flag that's brought up, it basically means that there was some form of error, geometrical error, found in that model or that model assembly. Then you have the option to look and see what specific issues you have. So maybe there's some self-intersections or open faces or zero normals. And there's an automatic repair function built into GrabCAD to fix that right there. So you don't have to go back to your CAD software. You don't have to go re-export STL or anything like that. It's also an important topic to bring up. GrabCAD can also take a native CAD file if you were familiar with GrabCAD already. So it just increases your throughput and the ability to get to printing faster and reduce that processing time. Scheduling, another very important aspect of GrabCAD Print. You have a built-in Gantt chart, both on the web account and also in the GrabCAD app itself that you're using to process and queue up jobs. You see the names of the jobs. You see what jobs are being printed, what percentage of it is finished. You're seeing the machines and their status. You could even see if there's insufficient models. So maybe I queue up a job that requires 25 cubic inches of material and there's only 20 loaded. I can queue that up, but it will not print before it tells me that there's not enough material. So you can optimize and get even better understanding of what type of inventory you need to have on hand at any given time and have a minute-to-minute understanding of what your consumption is across your entire fleet. It doesn't just have to be one specific location. You also have printer options as well. So with our polyjet systems, you need to clean those heads every time you print. It takes about 5 minutes, but it's important because since it starts in a liquid resin form, you don't want those heads clogging up with that material. Now, if you need to print something over a long weekend, you don't want that job sitting on the tray and those heads dirty for a day or a couple of days. So what you could do is actually schedule a specific time you want that job to print, So you can do the math to figure out exactly when you want it to end. So in this example, 9 a.m., so you're ready to go. It just finishes as you get into the office and you clean right down there. So you not only have that part done that Monday morning, but you also have a clean printer ready to have some printing done immediately. And then this, like I said already, it's also available on the browser version of GraphCAD as well as the app. Now, into remote monitoring. So going from improvement to remote monitoring. Emails are sent automatically from the GraphCAD server over to the operator that is working on something. So in this example here, I was sending something to our headquarters location on our specific machine. Please ignore the goofy names that we give our machines. We need to keep our sanity sometimes, so we like to have fun at work. Also, the name of the job. So making sure that you have everything associated. So this is a 911CF job. This is our ID number to keep track of things internally. And it lets me know if that print was paused, if it was stopped because of an error, if it was finished printing, and even with PolyJet, if the build was actually taken off the tray, because again, you want to make sure that you have clean heads and a clean build platform. So you can get that information as it happens, just-in-time information for these purposes. So again, there's a lot of great monitoring. And also, if you have a smartphone, you could download another cell phone-based GraphCAD app where you could actually monitor your equipment remotely, again, anywhere in the world. So you can see what machine we're talking about. You can see when the job was completed, how long it took, what materials loaded up, even the IP address if you need to do some troubleshooting when you're abroad. And then depending on a certain machine, you could also have a camera view of what's going on. So you could actually physically view your job being printed, even if you're in a different country. So there's some really great information there. And then going back to the core of this conversation, reliability and repeatability, it's software and hardware. So on the software side, you could be using your 3D printers for any number of applications: concept validation, triple F testing, marketing models, jigs, fixtures, tooling, assembly lines, replacement parts, any parts, the list goes on. With all of that analytics on the back end and all that reporting functionality, you can detail exactly how much money and how much time you're investing into products and applications. So you can see what projects might be a little too costly, might be a little bit over budget, or what products are under budget. And then later on, you can see which products specifically and directly correlated to sales, and then you can see, okay, what was the revenue to cost ratio of this product that we took on. And the hardware, again, reliability and repeatability, you can specifically choose what orientation, what infill you want a part to have, and then print in that exact same configuration time and time again, over and over again, as much as you want. You have multiple part batches. We have printers that come in all shapes and sizes, rapidly different types of build chambers and build volume. So you can print all different types of parts that have your own miniature low volume assembly line happening with these parts. And on the PolyJet side, you can also have mixed trays, so multi-material models and things like that. So you can have not only consolidated assemblies like you have with FDM, but also, once again, multi-material, everything from rigid opaque to flexible, clear. All these different types of things can be happened in a truncated, more succinct manner for your printing needs. And the why. Why do we do this? Why do we want analytics? Why do we want numbers? Why do you need to manage with data? It's changing the subject and changing the conversation from anecdotal to factual. If you're trying to talk to upper management about getting some initiative going that you know is important, and you don't have figures backing that up, it's just he said, she said. If there's a problem for you, if there's any number of issues that you know the answer to, but you can't prove it, well, the answer's right there, you can't prove it. But by having accurate reporting and having facts and figures to back things up, you're able to explicitly spell out how not only this is a problem, but how this affects our costs and our bottom line. And if you have a product in mind, how much money that could potentially make in cost savings or added sales. And the why to those metrics, once again, is if you want to stay customer focused, again, voice the customer in mind, you need to be deliverable focused. And if you need to be deliverable focused, you need to be metrics focused, because you can only figure out how to get and achieve that deliverable from those metrics, and those deliverables are based on customer feedback anyway. 5S. This is a fun one with 3D printing. 5S literally stands for 5 S words that make up for a healthy and efficient process and facility. So the first is set. that. So literally straightening items in a specific order. So you don't have to go running around looking for tools, which happens constantly in different companies. Shine, making sure things are clean, if the work environment is clean, so people are enjoying their time more at work and they can operate more efficiently because they don't have to constantly clean up messes or, again, look for their tools. Standardize, so standardizing improved approaches that you're figuring out. After you clean, after you straighten and organize things, let's maintain that and make sure that we keep that going. Sustain, so again, sustain those standards over time because they do naturally erode. Things come up, schedules get turned around, people go on PTO, people get fired, people leave companies, things change. So you need to have processes in place that can withstand the test of time and still be improved as equipment and people change. And then finally, sort. So optimizing the workplace layout. So again, making sure that you have specific areas dedicated to certain focused applications or work done to ensure that every square foot that you are paying for is being used appropriately to increase revenue for your company. And here's some pictures as more examples. So again, so step, having things specifically detailed, designed, and printed for very specific parts that you need for your process and labeled, having very clean, organized workflows and things such as that. Standardizing approach, so having assembly jigs fixtures to make sure that your process can be repeated and is replicable. Also having things like go and no-go gauges to make sure that, okay, if this does not fit in this check fixture or check gauge or check jig, we already know what's going on. So being able to standardize the part quality is important as well for your finished products. Sustaining, so this is an example of using 3D printing on a CMM machine to again hold that piece in place to make CMM measuring even easier. And then sorting, so again having every single toolbox, every single area where you have tools or a human interfacing with your technology, very neat, very organized. Every single aspect of your process has a specific prior proper place to put these tools or to put these people. Now, the cost of poor quality, COPQ for short. Here's a really important one. This is the iceberg example that we talked about earlier. Poor quality does happen, right? So it's not completely avoidable, but the challenge is to try as best you can to avoid it. A good way of thinking about COPQ is what costs would go away if we delivered things better or delivered things perfectly. So think about all the costs that you incur just from a lengthy process or having delays and things like that, or a lot of failures in your model or a lot of defects per batch. These are important things to think about. Again, going back to being able to speak to upper management, you need to be able to put a price on it and to show that it does have concrete and measurable consequences. And another way of looking at COPQ is it's the gap between what you would like your product or service to be and what it actually turned out to be, which, as a lot of us know, is not always exactly the same. And you can measure COPQ by the cost of labor to fix problems. If you keep delivering parts that are broken or faulty, what is the cost that you need to divest your labor to fix those problems? What is the cost of extra materials used by having to reprint or remanufacture items that had defects that you could have figured out many steps ago in the process? Higher costs of processing because you have outdated systems or outdated software, lower customer service levels because you're taking so long to deliver, which directly correlates to potential loss of market share, and then once again, the big bad, cost of lost opportunities. Rapid prototyping is an answer to that. So being able to print things, print hollow things, by the way, make sure that your prototypes are low cost, you can quickly reiterate, so you can print out multiple versions of a part in a matter of hours or days or weeks, depending on how many you're trying to do, to constantly reiterate and have a handful or a box full even of different examples that you want to pitch to your boss or pitch to your team, so you can figure out where you want to go even faster, and then eventually have faster go-to-market strategies. And then again, almost all these problems can be prevented if proper monitoring and control systems are in place, which is purely predicated on having good analytics and metrics backing everything up. So again, COPQ, the way you can calculate that is essentially external failure costs plus internal plus appraisal costs and plus preventative action costs. And there's a step-by-step example on how to go about this. So step one, ID the product or service we're talking about. Figure out the average selling price. Percent of defective units found before customer delivery. So how many times do you find a broken part or something that went wrong on your assembly line that you need to just straight up throw out because it's completely wrong or it's broken or fractured or it's manufacturing correctly? What's the cost per unit of your production? How many do you sell a year? What is the percentage of returned products, services, or parts that you need to deal with your process? And then of the returned units, what is the percentage of customers that will take their business elsewhere because they were so dissatisfied with a faulty product or service? And then to give you some real numbers to think about, here's a quick example. Product was a lawnmower. The average selling price of a lawnmower was $100. They were able to find 6% defective before sent to the customer. The cost of each unit, not including those defects, is $25. How many units did they sell? They sold 25,000 per year. So think about how much that 6% increase in terms of cost. What percentage of the units are returned as defective for a full cash refund? 4%. And then the estimated lost customer base is 2%. And we could give you a template so you can see all these things and how you calculate some things for your own product or service. But in this example, the estimated cost of poor quality per year was $250,000. And a way to consider how this affects your business, think about how many products you sell a year, how much those cost, and how that number changed with your process. It might make you sweat after a while as you start to think about how those numbers stack up. And again, if you don't know what these metrics are, if you don't know these numbers, then you absolutely need to implement them, because you need to be able to look at this and see the bigger picture and how many costs that you're paying for that you might not even realize yet. So another thing to hammer out cost is value stream mapping. And value stream mapping is essentially looking at the full process and only putting down the specific steps that produce customer value. So in a typical product development process, you're going all the way from product approved, then the functional design, the design approval, building the prototype, testing the prototype, approving the prototype, product plan, the supply chain plan, the marketing plan, the final approvals, and then finally you release to production. That's all well and good, but the actual product development has delays in between all these things. So that delay could be a minute, an hour, several weeks, depending. Think about think about all these steps in your business and how long it takes to actually go from a product being approved to that product being released. It might take way longer than it should. With 3D printing, you can switch this up a little bit. So again, here's the actual product development with delays. Here's also 3D printing. You're removing more than half of these things because of how quickly you could reiterate and print out different prototypes of 3D printing, getting dozens upon dozens of different reiterations done quickly in a matter of hours or weeks to get to your team or your boss or your upper manager to figure out exactly where you want to take things. Then comes the product plan, supply chain plan, marketing plan, final approvals, and finally release to production. So now an example to look at as well, and this is a chart that CAD worked up to think about what it takes to do the 3D printing process. Historically, if any of you have had 3D printers previously, you have to have your designer or engineer make a model. How long does that take? The file transfer, how long does that take, and how much loss do you lose in quality of that part? Then having printer operator go into any number of different design studios or software studios to process this file properly for your printer, then eventually print, take out the printer, and then you're finally done, not including how many times you do that over again based on your volume. So something like GrabCAD, it's expedited exponentially. So you go right from your CAD designer or engineer. You can do all of these steps in this one software. There's no file transfer required, so you can get that final part much quicker. And if you're concerned about Wi-Fi access or being on a cloud-based server, you can talk to us about cloud workarounds, because we do understand there's confidentiality concerns with some customers, especially in our defense and defense contracting businesses. We have workarounds for that, and you can actually operate this offline too. So you could give us a ring if you're curious. It's important to note, a bad process beats a good employee every time. And typically speaking, your best employees will let you know quickly if there's a bad process. They're frustrated by other employees that want to do something. They're frustrated by vendors not sticking to their word. They're frustrated by the time it takes to go from step A to step B. You're most likely going to hear this feedback. It's important to listen. And again, no matter how good that employee is, they can't do anything if it's taking a vendor 3 weeks to get something accomplished. So a bad process is always going to trump a good employee, regardless of the cost.